I'm Shalabh. I'm one of the co-founders of Assert AI. We are a computer vision platform, and I'll talk about a bit about computer vision in a bit. But essentially, what we do is we are a software company that can take a video stream and make sense out of it, right? Practically, what that means is we can take any standard purpose camera. So you have a security camera that's hanging off a ceiling, the video stream out of it. Think of it as it's mimicking the ability of a human eye, right? So if you were looking at that video stream and you could observe things in it, we can get the software to observe the same things and create metadata out of it, right? So it's essentially creating visibility. That's what our platform does, right? If you have a camera, we can create visibility into a process. I mean, you're right. AI has been around a while. Computer vision has also been around a while, right? I mean, even 10, 15 years ago, there were healthcare startups who were doing computer vision particularly in healthcare. We have seen instances of, mimicking a radiologist, for example. So taking images and saying, does this image have something worth looking at? And can I have the algorithm do the first pass and then use the radiologist as a second pass, right? So in that sense, not new, right? What has changed is the processing available now, the compute available on Nvidia, for example, on Nvidia chips, basically makes it a lot cheaper to do it at scale. And it's going to get cheaper. It's still not very cheap, but it is much cheaper than it used to be. The one thing I will say that has changed, and we are doing a lot of early stage experiments with, is VLM, which is video language models, which is more a offshoot of LLMs. And what VLMs would be able to do is the standard computer vision models, which are detection models, which are essentially the ability to detect an object, to be able to see an image and say this is a cat or this is a pallet or this is a door, right? Uh, what they miss is they are not able to get context. So if I give a video to a traditional computer vision model and say identify human beings in it, it can. But if I say in this video are people fighting, very hard for a traditional computer vision model to do, because fighting is context and time, right? I mean, one snapshot can't tell me anyone is fighting one. Multiple snapshots may also not tell me, maybe people are play acting. What VLMs theoretically do is they do that a lot better. They can take the context and are able to layer the context on top of the video, right? So we don't have VLMs deployed in production yet because there is still some more R&D and work that needs to be done. But they are very promising because they could truly level up what computer vision can do. They are still expensive though in terms of computes, but again, compute will become cheaper, so matter of time before that becomes easy to do as well.
That's fascinating. I've not heard of the VLMs before, so that's very interesting. So you're saying is the VLM the main first intersection here between generative AI and computer vision, or is there
Yes.
other intersection as
Yes.
well?
That is the biggest. I mean, there are other intersections, but the others are more, we use LLMs or generative AI already to do stuff like I create data from traditional computer vision models. How are you going to consume that data? So I put an LLM on top of that, and you can, the LLM can write a query on a database and help you consume that data. So think chatbot, right? I mean, a chatbot that is specifically looking at the database, the metadata that I created from my computer vision model. But that's not really truly, that's just a consumption layer, right? I mean, instead of a dashboard, I have a chatbot. This is a better chatbot because it's an LLM compared to a traditional chatbot, which was not an LLM. This is the true full intersection where the VLM, where the LLMs get embedded into the pipeline of how you do computer vision. So that's what VLMs
Interesting.
are.
So
Yeah.
so we could break this down like you were saying. There's the element of like gathering data. There's the
Mhm.
element of like making sense of data, and then there's the element of how do I communicate and interact with that data. Is that a good breakdown?
Traditionally, yes, the VLM actually will sit in the gathering data itself. If the VLMs work as intended, they would sit in the gathering data itself. They would not be today. The LLMs are sitting on top of the data being already gathered. But with the VLM, you would integrate that into the pipeline of how you generate the data with computer
Because
vision.
you're specifically learning from the environment that you're.
Yes, yes, with the context, yes,
Got it,
yes.
got it. Yeah, otherwise it would probably be just too massive of.
Yep.
Got it. Yeah.
More than massive. Again, like take that example of how do I define two people are fighting?
Right.
Um, when you as a human being look at a video and decide people are fighting, it's not just your vision. Your eyes are seeing something, but there is a context in your brain on what they are doing that tells you that they are fighting. which is much better translated in language, that context, than in video, what data video frames can generate. So that's the VLM interaction in the pipeline.
That's so interesting because I feel like, I mean, you've been in our roundtables, right, and sessions. There's a conversation that kept happening a couple times, which was about context. And so the it's like one thing to collect all the data from across ERPs, WMSs, TMSs, and whatnot, but it's another to then have the correct context
Yep.
in my supply chain speak, if you will, to make sense of that data in the correct
Yep.
way. And then we
Mhm.
even have the MCP servers, right, which are
Yep.
a context layer. Can you speak more about the importance of context? I mean, you talked about it again in the video sense, but in the more general Gen AI sense.
So I think I can let me talk about context more in the even in the computer vision sense. I will not talk about in the Gen AI sense because I'm no expert in Gen AI, right? Um, and we see this a lot in the work we do. When we first, again, going back, what do? We have a camera. You give me the camera feed. I can observe it. I can create visibility, right? So you give me 100 cameras. I look at 100 cameras, and now I have visibility. But my visibility is still limited to what the camera is seeing. It does not know what else is going on, right? And unless I can connect to what else, my all my observations are in isolation. So I might see a pile up of a certain type of inventory somewhere. So what? Right? It's when you layer the context that I might get from an ERP that tells me, oh, I am supposed to receive a big shipment of this brand today. I have not received it. Or I don't see enough boxes of that particular type here. That means I have not received it. Only then does this information, the context, it is only within that context that it becomes valuable, right? So I think, yes, I've heard that conversation about context. It's super important. That doesn't only come from, it doesn't only come from necessarily Gen AI. It can come from ERPs. It can come from other data sources I have. But the whole picture only makes sense when it's put together. Otherwise, you're getting isolated pieces of data that are not very usable or actionable on their own.
Got it. Right now makes sense. And I know within your applications, right, like some of the way that you try to make more sense of what's going on in a warehouse is like scanning labels, right, or identifying movements and so forth. So there's probably some stuff that is relatively easy, I want to say, to understand what's going on because, hey, I take a picture of a barcode label and now I can make sense of that. But it's harder to understand of a situation like you were saying. There are two people. I'm monitoring people doing stuff, and that doesn't like how do I interpret their activities, their movements, their interactions, and make sense out of that, right? They don't have a barcode on them to say, what they're doing.
Yes, like yeah, I can sort of add to that and add more color to some examples of what you can see. Um, so let's say you're unloading a truck, and two people are supposed to be unloading a truck, and it's supposed to take 2 hours and 25 minutes to unload a truck, right? What I can see from the camera is how many people are unloading a truck, right? Um, so let's say I see only one person unloading a truck for 15, 20 minutes, 30 minutes, right? Sure, that's the problem. There should be two people unloading a truck because if it's only one person unloading, it's going to take you double the time, right? If I am connected to the labor management system, I would know if someone is assigned or they are not even assigned, right? If they're not even assigned, or if I'm connected to the labor management system and I know I've had 20% attendance issues today, there's nothing you can do. I mean, there is no value in, I'm not telling you anything new. You already know that no one is assigned, right? So it's that context comes from other pieces of data that we can integrate to. And if I see, oh, someone is assigned, but they are not here. Now, they may not be there for a good reason, but does anyone know they're not there? Right? So it's that the more you can integrate other pieces of data, the more context is available, the more our data becomes useful.
And the more relevant the recommendations, like you said, if I already know
Absolutely.
that 20% of people are not here today, then you don't need to give me an alert about the
Yep.
situation. But
Absolutely.
if everybody's here, this is supposed to be happening. So I understand. Yeah.
And just, sort of adding a little bit of more color to
Mhm.
that, the way I see it is if you are trying to do quality applications with computer vision, you don't need a whole lot of additional context because quality is usually good or bad. Once you tell me what is good, I can tell you whether this is good or not, right? And in isolation, it needs to be good. If it's supposed to take you, if you're supposed to move a box from point X to point Y and you leave it somewhere in between, that is quality bad. I can tell you quality is I don't always need a lot of context, right? Safety, the same thing. I don't really need a lot of context. You're supposed to wear a helmet, you're supposed to wear a helmet. I mean, right? It's where longer term unlock like productivity and efficiency is where you need a lot of context. That's the computer vision alone is not good enough to do much. And that's something we see with a lot of our clients when we start working. We typically recommend we start with something like a quality safety sort of use case because you can get it's a low hanging fruit. You can get ROI more quickly. You don't need a whole lot of context. You don't need 7 different integrations. But if you want to get true long-term value, you need more integrations with, with ERPs, labor management, so on and so forth, to get long-term redesign of your workflow.